Hi everyone, my name is Amitesh, and in this video we're going to thoroughly analyze radians versus degrees. Now the first time I saw radians I was super confused, but my goal for this video is to ensure that once you watch this video, you're 100% in command of radians and degrees and really understand them, and also you'll get to see why alien civilizations very far from us would discover radians for sure, but may or may not discover degrees. So radians are actually the more natural thing, even though we're used to degrees. Watch till the end to find out why that is. So let's get started. So radians versus degrees. So what we're going to do is we're first going to talk about the concept of angles, and that's going to naturally lead us into our discussion. Okay, so what I'm going to do is I'm going to draw a unit circle. Okay, so a unit circle in the plane, if you like. So it's a circle of radius 1. So I'm just going to draw it like this. It's a nice circle of radius 1, and we want to measure angles on the circle. Okay, so if we draw a arc, or not an arc, but if we draw a radius on the circle, I'm going to use red, then basically it's going to make an angle with the x-axis, which we can call some number. We can call it theta. This is a Greek letter. Now, the angle can be anything. The angle could be 30 degrees, 45 degrees, 60 degrees, but these are all arbitrary measurements. If you think about it, for example, we say that a right angle is 90 degrees. Well, what does that even mean? I mean, 90 is an arbitrary number, right? There's nothing special. I mean, why don't we call this 100 degrees? Why don't we call this 50 degrees? We happen to call it 90 degrees, and we happen to call a full revolution going around the circle as 360 degrees. Now, the point of radians is it's a much more natural way of measuring angles than these arbitrary sort of numbers that we're associating to them. And the reason for that is, imagine that I draw a line, right? And imagine that you are an ant that is going from this point on the circle along the circumference of the circle all the way up to that point, right? That distance that you will travel will be a perfectly fine and natural measurement of how much kind of space is there between these two lines, between this red line and between the x-axis, right? That angle is going to give you, or that distance is going to give you the best understanding of that, and it's not going to be an arbitrary number that humans have discovered. It's going to be some number that is very natural, because you've taken a circle of radius 1, it's going to be a very natural number that's going to represent, in some sense, the distance between these two lines, but also the angle. Okay, so let's now think about this in further detail. If I have the angle of 360 degrees, right, then the distance that an ant would have to go all around the circle once. Well, if you have a circle of radius 1, then the formula for the circumference is 2 pi times the radius. So that means that if you have 360 degrees, then this would correspond to 2 pi of distance traveled around the circle. And this is the start of radians. We think of 360 degrees as 2 pi radians. And 2 pi is very natural. You know, pi would have been discovered by alien civilizations everywhere. Okay? 360 maybe not. 360 is a human-made construction. But we can keep going with this. Suppose we instead have half a circle, right? Instead of going along the whole circle, imagine that we have a semicircle. So I'm going to draw it like this. I'm going to even remove the axes. Imagine we have a semicircle. So let me kind of put this like this. Okay, keep the axes. But I have a semicircle that kind of goes all the way around once. Now we say in math, we say that's 180 degrees, right? It's kind of a straight line. You've kind of gone 180 degrees around. But from the perspective of the ant, it's traveled pi. A distance of pi, because that's going to be 1/2 the circumference of the circle, and the circle has radius 1. Okay, so that means 180 degrees is going to correspond to pi radians. So this is actually a cool little table we can use. So I'm going to kind of draw it like this. So this is degrees versus radians. I'm going to put it at the bottom. It's going to be degrees at the bottom and radians on the right, degrees on the left. Okay, so degrees versus radians, and so we can keep going with this. 180 is pi. What do you think 90 degrees is going to be? 90 degrees is what you're going to travel if you just travel kind of one kind of quarter circle, right? You just kind of travel. So here, I just sort of travel from here, this point on the x-axis, all the way to this point on the y-axis. That's going to be an angle of 90, which is a human-made construction. But it is a natural thing to say it's pi over 2 radians, because that's the distance you travel. So you get pi over 2 here, and you can keep going with this. What do you think 60 degrees is going to be? Let's not even think about the picture. Let's think about it as a proportion of the circle. Because remember, the circle is perfectly symmetrical, even though I kind of drew that loop badly. It's perfectly symmetrical. So if you take 60 degrees, which is 1/6 of 360 degrees, the radians are also going to divide by 6. So you're going to get 2 pi over 6, and 2 pi over 6 is just going to equal to pi over 3. And finally, as another exercise, I'm going to ask you, what is 45 degrees going to be? What is 45 degrees going to be in radians? So sometimes what I like to do is I like to think about it in terms of known angles and kind of divide from there rather than starting off with 360. So once you get the hang of 180 degrees is pi radians, you can also sort of see, okay, 90 degrees is pi over 2, and 45 degrees will be pi over 4 because it'll be a half of 90, which is half of pi over 2, which is pi over 4. So it's going to be pi over 4 radians. Okay, so these are going to be the radians versus degrees table, and that's all there is to it. You know, whenever you want to figure out how many radians is how many degrees, you sort of start off with 360 degrees is 2 pi radians and work backwards. Okay, so let's do some quick examples and let's actually derive a formula. Now, I never use the formula personally, I just visualize it using this kind of table. But let's derive a formula so that we get a hang of it, and I want you to try to do that, okay? What kind of formula do you think you'd have to convert radians to degrees or vice versa? You know, what formula would you use? Okay, so let's kind of think about that. So here's an example. I'm going to start off by saying, how would the formula look like? Well, it's kind of proportional, right? If you sort of think about it, if you multiply its degrees times something, we don't know what that something is. Degrees times something is equal to radians. Because we know that 2 pi radians is 360 degrees, and then we know that, you know, it's proportional after that. If you divide 360 by 2, your radians also half. So it's going to be some constant times degrees is radians, and then what you have to do is just think about, I want you to figure out what that constant is. Okay, so pause the video, drop me a comment down below, explain what that constant is and how you found it. Because there's so many ways of looking at it in math. And then once you've done that, assuming you've done that, I'm going to get into it. So what we want to do is we want to think about one example. We know that 360 degrees is 2 pi radians, right? So we know that in particular, so I'm going to write this in red. In particular, we know that if degrees is 360, then 360 times this thing, which we don't know, is equal to 2 pi. So what do we have to multiply 360 by to get 2 pi? Well, we want to cancel off the 360 and multiply by the 2 pi, right? So divide by 360 to get 1, and then multiply by 2 pi. So it's going to be 2 pi divided by 360. That's all there is to it. That's going to be the constant. So that's determining everything. So now in our formula, we know that it's going to be 2 pi by 360. Just from that one example, you know, because if you find one example, you found out what that constant is, and you know that's the formula. So degrees times 2 pi over 360 is radians. So now we can kind of get into, you know, various examples, okay? So for example, let's take a famous example. Okay, 30 degrees. How many radians is it going to be? Okay, so 30 degrees is equal to how many radians? Well, equal to question mark radians. Well, we can use our formula. Okay, we can think of it in terms of our formula or in terms of dividing. You know, I like the division. 30 degrees is 1/12 of 360. So it's going to be 1/12 of 2 pi radians, because 360 is 2 pi radians. So it's going to be pi over, 1/12 of 2 pi is going to be pi over 6. Okay, so that's going to be 30. Or you could use the formula. So you could say that 30 times 2 pi over 360. So that's going to be equal to, well, that's going to be 60 pi over 360, which is going to equal to pi over 6. Okay, so 30 degrees is pi over 6 radians. Is another very important value to figure out. So now I'm going to ask you one last question to sort of end the video. Is, suppose I gave something like, say I did 3 pi radians. Okay, how many degrees that is? So we can go beyond 360 as well. Okay, so 3 pi radians is how many degrees? So 3 pi radians, how many degrees is that going to be? Pause the video, think about it yourself, use the formula or visualize it, you know, visualize some standard things like 2 pi radians, etc. So let's do that. So I'm going to think of it like, personally, I think of it as pi radians is 180 degrees. And then so 3 pi is going to be 3 times 180. Okay, so because 2 pi radians is 360 degrees, so pi radians is 180. So it's 180 times 3. Okay, so 180 times 3. And you can also say that's going to equal to 540 degrees. Okay, So if I've got that right, it's 540 degrees, I've got that right. So these are things to just internalize, but I encourage you to practice, play around with it, try out some examples, really master it. It's super natural, you know, radians, because it's a unit circle and traveling around it, it doesn't matter where in the universe you are, that's an objective measure of kind of the angle, which is philosophically measuring the space between the two lines, right? So if you think of the space between two lines, if both the lines have length 1, and then you sort of say how much distance I travel, right? That's a much better measure of angle in nature than just defining an angle which is arbitrary, because you have to say what is a right angle, right? What is a right angle? It's 90 degrees. That's an arbitrary human-made construction. Okay, so I'll explain in another video why we have said that right angles are 90 degrees. That's a really interesting point. But I hope you loved that video. My goal is free accessible math education worldwide. I hope you mastered radians and degrees after watching this video. I hope I helped support you. Spread the word to family, friends, like, subscribe, watch my videos. It means so much to me. I'm so happy you've watched this far, and I hope I've done my best to support you. Wish you all the best, and I'm super excited to see you in the next video. Drop a comment down below with any thoughts or comments or anything you like, and I'll read all comments and respond to as many as possible. Super excited to see you soon. Take care.